is it always the case that two even numbers, any two even numbers multiplied by each other is going to give you an even product? Well, let's think about it, right? Think of a few examples. 2 times 4 is going to be 8, that's even. 2 times 6, that's 12, that's going to be even. 4 times 4 is 16, that's even. 8 times 4, or actually let's do 8 times 6, that's going to be 48, that's even. So just off the top of our mind, the first few integers that are even less than 10 are going to be even, so that's probably true. So first, let's write this as a mathematical statement. Well, what are we saying? We're saying that any integers a, b, for any integers a and b, if a and b are even, then a times b is even. Okay, great. Let's identify our p and q. Well, we have an if, then, so it's going to be quite simple here in this case. That's our p. This is our q, so q, oh, sorry, other way around. Q, P, and then just so we're reminded of what we're doing, we're saying that's A and that's B, and we're saying this is A times B. That's what we're saying, right? Great, so now we need the definition of even. Well, let's remind ourselves, the definition of even is going to be some integer x such that x is equal to 2k for some k that's also an integer. Think of some examples. 2, if x is 2, 2 is equal to 2k, rearrange for k, k is 1, 1 is an integer. If you put 3 here, which is not an even number, k won't be an integer, right? If you put x is equal to 3, rearrange for k, you're going to get 3 over 2 is k, and 3 over 2 is not an integer. You can do this for any odd and even number that you know to just test this definition. Okay, great. So let's start proving this. This is a for all statement, which means it's a let, right? That's how we start a for all statement. So let, and then we're going to suppose p. Let a comma b be integers. I like notation. People sometimes like to write them out explicitly. Let a and b be integers. You can do that. I prefer using symbols because it's good to get comfortable with them, because then you can read math and math books and math statements much easier without having to translate them in your brain. It also makes writing a lot quicker and neater. So let a and b be integers such that a and b are even. Then let's define our a and b. So let's say then a is equal to 2m and b is equal to 2n, and let's also define what m and n are, because now we've introduced to the reader, hey, there's something called m and n, and they don't know what that is. So let's say where m comma n are also integers. Great. That's the first sentence of our proof. Next, we're going to want to get from a times b is even, right? We want to get a times b is going to be something in the form of this, x equals 2k, where in our case, k is going to have to be an integer, right? So let's write this out. A, therefore, comma, a times b. So therefore, a times b is going to be, let's unpack what we just defined a and b as, 2m times 2n. Awesome. Well, how are we going to separate this, right? Well, we can rewrite this as 4mn. Okay, well, this is weird. We just got rid of our 2 and we need 2 times some integer. Okay, well, let's think about this. Can we factor out a 2 somehow from this? Well, we can, right? We can just say this is the same as 2 times 2mn. Now, this is very counterintuitive. You would never really be taught in high school or elementary school to break 4, to multiply 2 by 2 like we did here to get 4 and then break it back up into 2 times 2. But in this case, it's helpful for us because it let us merge m and n. Okay, well, we got this in the form that we needed, which is this form, x equals 2k, where in our case, a cross b, a times b, is going to be our x, and 2mn is going to be our k, right? X is equal to 2 times k. So now we need to explicitly tell the reader that 2mn has to be an integer. Multiplying two integers, or three integers in this case, is going to still give you an integer. There's no way to multiply two integers, at least that I can think of, where you're not going to get an integer, where you're going to get some complex number or some decimal number, right? So that's what we need to tell them. So since 2mn is in the integers, the set of integers, then a times b is, oh, actually, let's write a slightly more complicated sentence. Then the product of a times b is even, so the statement is true. Okay, awesome. I like to add this part sometimes I don't. It really depends how I'm feeling. Some proofs are so simple that you don't really need to add that statement, but if you have the extra time on a test or on a paper or something, you might as well remind the reader that, hey, you just showed the statement's true, right? If you want to add more detail or be more explicit, or in this case unnecessarily create more variables, sometimes it's a bad practice, sometimes it's helpful for clarity. I think it's helpful for people that are learning proofs to better see why this logic works. We can say, let 2mn equal, let's call this w. W will be an integer. Since 2mn is an integer, okay. Then a times b is going to equal to 2 times w, which by definition of even makes a times b even. You don't want to ever state in your proofs the definition. So what you actually want to write is just this part beneath my hand. Everything up here should be things you have in your mind or things you write in your scrap paper to like remind you, right, of what you can use. Because sometimes you'll have a long proof and you'll have a lot of statements you'll need to prove. Like in this case, we just needed to worry about even, right? But if you have like 30 things, you might not need to use all of them, but it's nice to have a list of all the definitions. So when you're stuck in your proof, you can think to yourself, did I define even? Did I define rational? Did I define divisibility that maybe I can use to get to my conclusion somehow? But in this case, it's pretty straightforward. It's not very long. This is very, very short proof. But yeah, this is how you prove that any two even numbers, whether they're the same or not, is always going to be, the product of them is always going to be even.